Support reactions influence lines in a simply supported beam. Let's look at an example. There is a simply supported beam. The beam has two cantilevers. A moving load of magnitude 1 unit affects the beam. That load moves from one point to another across the simply supported beam. This type of load is typical, for example, for bridges or overhead cranes in production halls, etc. That it's not very convenient to draw familiar diagrams of internal forces. Therefore, influence lines are drawn. The difference between diagrams of internal forces and influence lines is that diagrams show the magnitude of internal forces in any cross-section of a structure from a static load, and the influence lines indicate the magnitude of internal forces in certain cross-section from any moving load position. And as from any load, support reaction occur on the supports. Well, to draw the influence lines of support reaction from the load effect, the equilibrium equations are used. But first, let's remember the signs rule, which is used for writing the equilibrium equations of the structure. The minus sign is taken when the moment is directed counterclockwise, otherwise the plus sign is taken. Now, let's write the equation of moment equilibrium about point A to determine the support reaction RB. But for this, we must know the distance from point A to load F, and as the load is movable, this distance is variable. Therefore, we denote this distance by the variable x. In this example, we took the origin of the coordinate system at point A because it's convenient, but in general, it can be taken at any point line on the axis of the beam. So, from the equation of moments equilibrium about the point A that was written, a linear function is derived. That is the equation of a straight line. And this means to draw the influence lines is enough to determine the coordinates just of 2 points. It's convenient to take the variable x equal to 0 and 7. Substituting 0 and 7 into the equation instead of the variable x, we get that the support reaction RB is 0 and 1, respectively. Now, let's plot these 2 points on the diagram and plot the influence line. In doing so, positive values are plotted above the abscissa axis. Let's see what the drawn influence line means. Consider, for example, when the load is at the point with coordinates -5, 0. Then the ordinate of the point on the influence line with coordinates -5, -0.71 is the magnitude of the support reaction RB when the moving load F is exactly at the point with coordinates -5, 0. Or consider the case when the load is at a point with coordinate 3, 0. Then if a line is drawn to the intersection with the influence line, the ordinate of the intersection point is equal to the value of the support reaction RB. Well, now let's write an equation for the moment equilibrium about point B to draw the influence line of the support reaction RA. As in the previous case, a linear function is obtained. To draw the influence line of the support reaction RA, it's also enough to determine the coordinates of only 2 points. In this case, as in the previous one, it's convenient to take the variable x equal to 0 and 7. If we substitute 0 and 7 into formula 2, the support reaction RA will be equal to 1 and 0 respectively. Let's also plot these coordinates on the diagram to get the influence line of the support reaction RA. Now let's understand why the influence lines are built for a load equal to 1. It's very simple. When the magnitude of the moving force is known, it's enough to multiply its magnitude by the ordinate of the influence line to find out the value of the support reactions. Thanks for watching. Please like and subscribe to the channel.